So 2.7 is solving equations in one variable, and one of the pieces we're going to talk about is extraneous solutions. We're also going to be looking at how to deal with fractions, which I know is one of those things that, you get taught every year, but somehow we always stress about it every year. Somehow we always forget. So we're just, it's some basic review. It's not even so much pre-calc today as it is algebra type review. Okay, so it's just, I know that makes it worse for some reason, but that's what it is. So we're going to look at some examples and go from there. So example 1, x plus 3 over x equals 4.
Thoughts?
Well, solve for x.
No.
Valid. We're going to solve for x.
Multiply x over.
And why are we multiplying both sides by x?
Cancel.
Yeah, we're going to get rid of that fraction. We want to get rid of the denominator. And so to get rid of a denominator is being divided by x, so we're going to multiply by whatever the denominator is. Now, if I multiply, I can't multiply just that fraction by x. We multiply everything by x, right? So I'm going to multiply my left side of my equation by x and my right side of my equation by x. On the left side, we know to distribute. X times x is going to be x squared plus
That's so much easier.
3 over x times x.
3x. No, just
3.
Just 3 because 3 over x times x, the x's will cancel, right? So it'll just be 3 equals 4 times x is 4x. Nothing to cancel there. Okay. Now we are definitely to a traditional algebra equation. You guys have to be able to tell me how to do this one. We have to get past the, I don't know what to do. Yes, this is definitely something we need to know how to do.
Yes, I know how to do this.
Subtract. I had my hand raised.
Okay,
You
so
subtract 4x.
when I see quadratic terms, so x squared terms, x terms, and number terms,
Factor.
general rule of thumb is going to be try set it equal to 0 and see where we can go from there. Okay, we're going to hope for factoring. If factoring fails, what's a backup plan?
Quadratic formula.
Quadratic formula. So we've got some plans there. So if I subtract the 4x over, order-wise, I'm going to write this as x squared minus 4x plus 3 equals 0. You guys have seen some equations like this on your quizzes and tests this year. And for some reason, they're always rough.
That's why.
Okay, we have to know how to do this. This is knowing your algebra. What do I do with x squared minus 4x plus 3? Does it factor?
31. Yes, it does.
I wrote the parentheses, so that's your hint that it does.
X
Negative
minus
3. X minus 3. And negative 1.
Okay. X squared breaks into x times x. I need my two numbers to multiply to be 3 and add to be negative 4.
Minus 1, minus 2.
So since they multiply to be positive, add to be negatives, they're both going to be minuses. In this case, 1 times 3 is 3. 1 plus 4 is 4.
Yes.
Now what is our official next step?
Set each factor equal to 0.
Right, set each factor equal to 0. So x minus 1 equals 0 or x minus 3 equals 0.
We're going to do all this.
And we end up with x equals 1 and x equals 3. Now, part of the concept of this lesson is also learning a little bit more about extraneous roots, extraneous solutions. Do you remember what it means if a solution is extraneous?
It's like you plug it in, and then if it doesn't equal the state, like if it's not a non-true statement.
Okay. So extraneous solution is a solution that we appeared to get through logical means, but when you check it, it doesn't work for whatever reason. Now, so one of the things I want to talk about is ways to check. One way that was just mentioned to check is to plug them back in. And this one would be pretty easy to plug the numbers back in, isn't it?
Yeah.
And so this is what I would call checking algebraically because the math is easy. I got nice, neat whole number answers. So an algebraic check sounds good for me. And so if I take 1 and I put it in my original equation, 1 plus 3 over 1 equals 4. Is that a true statement? Yeah, 1 plus 3 equals 4. Check that one. Now if I plug in 3, 3 plus 3 over 3 equals 4. Does that check?
Yeah.
3 plus 1 equals 4. Now, do you have to write out your algebraic check?
No.
No, not necessarily. I'm doing it here today just as a reminder, like this is a way to check. You don't necessarily have to write your check out, but there are certain problems today that you're definitely going to want to check your answer. Okay, and I'll talk about some of the reasons we would get extraneous solutions. And the fact that we have denominators here is a big thing. Because what do we know about denominators? They can't equal 0, right? So if we get answers that make my denominator equal to 0, that's one of the big reasons we are checking, because we're solving what I would call rational equations, the fraction equations. Okay. We okay with example 1 then?
Yep.
Okay, let's try example 2. X plus 1 over x minus 4 equals 0. Looks more complicated, but technically the steps are the same here. What was our first step last time?
Multiply both sides by x.
Okay, last time we multiplied both sides by x because x was in my denominator. So what am I going to do this time?
Multiply it by x minus 4.
Okay, I have a denominator that has the factor x minus 4 in it. So we're going to multiply the left side of the equation and the right side of the equation by x minus 4. Okay. On the left, right here, this x minus 4 has to multiply to the x, and it has to multiply to the fraction. Does that make sense? So we're taking that whole x minus 4, and we are distributing it. Now, for the moment, and you can go ahead and, when you multiply the x and x minus 4 together, for the moment, I'm just going to write it as x times x minus 4. If you go ahead and distribute, you're fine. I'll do that next step. Plus, what is x minus 4 times 1 over x minus 4? X minus 4s will cancel. What remains? A plus 1. Equals? What's 0 times x minus 4? 0. Are we okay with what we have here? Now, some of you already distributed, yes? If not, you're going to do so right now with me? Ah, what did you put here in place of 1? Nothing?
No, there's just nothing there.
Okay, that's a problem. You can't just cancel something into oblivion. Okay, so if we distribute
There's a small one.
x squared minus 4x plus 1 equals 0 is where we're at. Thoughts?
That's what I got.
Thoughts about where to continue from here?
Quadratic formula was very nice.
And why is quadratic formula being thrown out there?
Because it's
You
not
can't really multiply it to 1 and add it to 4.
Okay, our whole product sum idea doesn't fly here. I can't multiply two factors to get 1 and add them to get negative 4. So backup plan most often is quadratic formula. Okay, so quadratic formula.
What?
I'm sorry, I got something with you. Let me check. Erase that. Okay.
Negative b.
Positive 4.
Okay, positive 4. Plus or minus the square root b squared negative 4 squared minus 4ac minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 2 times 1. I definitely, see, this works so much better when I do this paper with pencil. I have another line in there, but okay, I'm just going to keep going to the right here. 4 plus or minus. First of all, it's kind of a silly question, but it is a valid question because we miss it so much, even at this level. It drives me crazy. Negative 4 squared.
16.
Oh, 16.
Positive 16, yes. So 16 minus 4 times 1 times 1. So 16 minus 4 is 12. All over 2. What do you know about the 12? 12 has a perfect square of 4 in it. The square root of 4 is 2. So square root of 12 can be rewritten as 2 square root of 3. So now I'm at the 4 plus or minus 2 square root of 3 all over 2.
And then you separate them. Then you
Okay.
have just 2
Then it's-
plus or minus.
Thank you.
Then it's 1 plus or minus the square root of 3.
2 plus or minus.
You cancel them into 4
Wait.
divided by 2.
You can't cancel out the 2's?
Well, okay, so here's the deal. This 2 in the denominator goes with
That one.
both terms
Yeah,
yeah.
in the numerator.
Yeah.
So here, 4 divided by 2 is
Oh, it's 2.
2
It said 1.
plus or minus 2 square root of 3 divided by 2 is
The square root of 3.
1 square root of 3,
Oh,
which is what your classmates were trying to correct you on because
Oh
you
yeah,
just
no, I was gonna go with
misdivided.
I forgot that I thought that you couldn't cancel the 2's because it's like 2 and the square root of 3 are like connected.
But they're multiplying.
You can, but yeah, you can because they're multiplied.
But if it's like that, you
Perfect.
can't cancel it out.
If instead I had if I instead, I'm going to erase this here in a moment, but if I had instead had this,
And you couldn't cancel.
I can't cancel.
Yeah.
Because there's no factor of 2 with the square root of 3 to cancel. Okay? So that's the difference.
So can you cancel the 2's though? Or
Nope.
No. Okay.
Unless, the only option I could say is I could say 1 plus or minus square root of 3 over 2.
Okay.
Because the 2 is still with the square root of
Yeah.
3.
So like that's what we did with the 4 and the 2. We didn't like yeah. Okay. I got it.
Okay? Okay, now, we had a denominator, guys. We had a denominator with a variable in it. We need to do some checking. Okay? Couple of thoughts as we check this. How do you feel about plugging these answers back in?
Like,
don't
the
really
next
want
one.
to.
Me personally.
I don't really want to either. I'll be honest, okay? So, while an algebraic check was an awesome idea up here, it's not really such an awesome idea here. So, I want to introduce a different thought, and that is instead of checking algebraically, we could check this graphically. Now, it still requires a little bit of work, but we have these handy-dandy calculators, right? Not a handy-dandy notebook, a handy-dandy calculator. So we're going to talk about how we could check this graphically. Now, as we check this graphically, where are the solutions on a graph? The x-axis, right? X-intercepts. So you can take, now, in order to do this, my equation is already equal to 0 in the beginning, yes? You can take your original equation, and instead of the 0, replace it with y. And so we can graph y equals x plus 1 over x minus 4. Okay? And then after we graph that, we check our zeros. So, grab your calculators and do that.
You sound
No, I'm left. Hannah's mad at me because I made a rainbow with her calculator earlier. And she opened it up and it was all over.
Okay, let's graph, please. You should be ahead of me here since I'm having to get my calculator out and having to switch the screen over. So,
Don't forget.
I've never seen a graph like that.
x plus, I like to use my fraction bar here, 1 over
There's Peter.
x minus 4. If you don't use a fraction bar here, you have to put x minus 4 in parentheses. Okay? My opinion, fraction bar is easier, especially since I think most, if not all of you, have that ability. Okay. Oof, calculator's in slow motion.
Mine was due.
Okay. Well, I see 2 places. My graph crosses the x-axis, right? How do I find what those values are?
Second trace. 0.
Second, trace, and go in and find your zeros, right? Old routine. Left bound, I'm going left of where it crosses the x-axis, enter. Right bound, I'm going right of where it crosses the x-axis, enter. Guess, going back to the area where it crosses the x-axis. And I get x is approximately 0.26794,919. Did this check just work or did it just fail?
It worked.
How do you know it worked?
Because if you plug 2 minus the square root of 3 in the calculator, that's what you get.
Okay, so do you have to do a little bit of side work here is the point?
Yeah.
Yeah, you're going to have to figure out, does 2 minus square root of 3 equal that? Okay? Kylie's telling me it does. And then,
Am I correct?
if I do this again, find the other 0, left bound, I'm left of it, right bound, whoops, I'm right of it,
Whoops.
whoa, and then 3.7320508. Does it work?
Yes.
Now, okay? So, if those match up, we're good, right? Options here. One option, and I'm guessing this is what Kylie did, is she on the regular screen said, okay, what is 2 plus the square root of 3?
Yeah, that's okay.
And what is 2 minus
Oh my god.
the square root of 3?
Looks like it worked.
Shocker, they match up, right?
Yay.
That's crazy.
Now, here you go, guys. I'm going to go back to my graph for a moment. Follow me. If I just hit the trace button, okay, which allows me to find an x value. If I just hit trace button, and then I type in 2 plus the square root of 3, it takes me to that x value on the graph. What does it tell me the x value is on the graph? The 3.73 number with a 0. Could we have just done that?
Yes.
Yes. Can we check the other one?
Yes.
Yeah, you can hit trace, and this time it's 2 minus the square root of 3,
I know.
and you find out that it's a 0.
That is wild. I did not
So
know
there's
that.
another option. Some of you, it sounds like, caught that option.
I think Mario caught that option.
Some of you did not. Thus, I'm
I
pointing
did
it
not
out,
catch
right?
that option.
Okay. Questions on example 2 then?
No.
Okay, so we've talked about algebraic checks, we've talked about graphic checks, and I will, give you one of the big keys here. What answer would not have worked in this original problem if we got it?
4.
We know 4 would not have worked, yes? Because since a denominator is x minus 4, I know 4 won't work. And that's going to be ultimately our big check, is if you get anything that makes the denominator 0, that's when we know we have the problem. Okay? I can tell you just by glancing at this, 2 plus square root of 3 and 2 minus square root of 3, they're probably going to work because they're not going to make my denominator equal to 0. And I didn't do anything else like take a square root or square an equation or take a square root or anything that might cause something not to work. Okay? Okay, ready for example 3? Working up the difficulty scale here, right?
Well, that's right.
Okay. Thoughts as we look at example 3?
I'm sure.
I don't know how.
I think I know how to do this.
Sophie, did you do this on your grad?
What do we see in the way of denominators here?
No.
It looks familiar.
Multiple possibilities.
We also did exit.
Well, both denominators, if you multiply.
There's a lot
They equal. Multiply
Okay.
is on the right.
So
Factor.
the fact that I see a single factor of x minus 1 as a denominator, I see a different factor of x minus 3 as a denominator. Right there, I know I have two factors in my denominators I'm going to have to work with. Now, when I see something that is an x squared minus 4x plus 3, one of the first things I'm going to check in this problem is, does it factor? Because there's a solid chance it's going to factor into the other two. That is very common. So one of the first things I want to do is let's factor this. What does x squared minus 4x plus 3 factor into?
X minus 3, x minus 1.
X and x, 3 and 1, both minuses. It just happens to equal the other two factors. So that's always one thing you're going to want to check. Now, with that in mind, what do we want to multiply our equation by to clear out all the fractions?
X minus 3, X minus 1.
Okay, we ended up with just two factors that are in common, right? There's an x minus 1 we see in a couple places. There's an x minus 3. Is there anything more than that ever? No. You would have to be careful if there was, say, if there was more than x minus 1. If there was more than one x minus 1 within a denominator. It's like if you had x minus 1 squared, you'd have to be more careful here. But if I have x minus 1 and x minus 3, we're going to multiply both sides of our fraction by, or equation by, x minus 1 and x minus 3. On the left and on the right. Now, every term, we are doing this. Now, I'm going to think of x minus 1, x minus 3 as a fraction by putting them over 1. On the left side here, this x minus 1, x minus 3 has to distribute and multiply by the first fraction and by the second fraction. With that in mind, what happens when you multiply by the first fraction? X minus 1 cancels with x minus 1. Now, that x minus 1 that I'm multiplying by, is it permanently gone? No, it's just for that term. Okay, so we realize that, right? So, what remains with this first fraction? The 2x that's on top and the x minus 3 that didn't cancel. Plus. Now second fraction. What cancels with the second fraction? X minus 3 cancels with the x minus 3. What remains?
X minus 1.
X minus 1, and technically you could say the 1 on top, right? However, does that 1 really matter? No, it's not going to matter. So you don't even have to write that. I'm just trying to make sure we get it. Equals. Okay, what happens on the right side? Okay. X minus 1 cancels with x minus 1. X minus 3 cancels with x minus 3, and I'm left with
2.
Are we back to more basic algebra now?
Yep.
You see parentheses, you guys know to distribute. 2x squared minus 6x plus x minus 1 equals 2. I see two things that need to happen.
Combine like terms.
Combine like terms.
Subtract 2 from the right hand side.
And in the process of combining like terms, make your equation equal to 0. So I am going to subtract the 2 over, but I'm also going to combine my x's. 2x squared minus 5x minus 3 equals 0. Okay, stay focused, please. Thoughts on where to proceed?
Quadratic
To do
form.
like,
Yeah, I know.
You could do the thing where you like split it down the middle and like do the
Okay.
Product of
AC.
Or you split
Okay.
it.
So officially, we have two options here. It does factor. If you start checking for product and sum with product of AC, there is a working pair, so that is an option. The other option is, could you do quadratic formula if you want? You can. Okay. I'm going to demonstrate product of AC here because we probably need to review it. I don't know. Maybe it's stuck in your heads, but for those of you that have forgotten, we're going to review it. So, product of AC means I need a product of 2 times negative 3, and 2 times negative 3 is negative 6. I still need a sum of the B term, which is negative 5. Man, I hate 6-5 combos. You have to be so careful. Is it 2-3 or 1-6?
1-6.
You have to watch the signs when it's a 5-6 combo, don't you? Because it could go either way.
Yeah, because you can't have -2.
So since it's negative 6, we need opposite signs. To get negative 5 with opposite signs, you're going to need a 1-6 combo, positive 1, negative 6. If you try and use 2 and 3, you can't use 2 and 3 to get a negative 5 if they have to be opposite signs. Okay, what do I do with that 1 and negative 6? I split the middle term. So it doesn't matter which order you split it with. Do you guys have a preference?
Surprised us.
Do the 6 on this side. Oh, I did the opposite.
Oh, okay.
But it doesn't matter. It doesn't matter. We can do it either way. It's really not.
I don't even know which way you meant by which side, so.
Okay. Just go for it.
Just do it.
Negative 6 on the left.
So negative 6 first?
Yes.
Oh, I did something wrong.
Doing that.
Okay,
See, I did the 1 on that side.
doesn't matter.
Oh.
Meet me in the end.
Just picking a side.
It's all
Okay.
the same.
2x squared minus 6x plus 1x minus 3. If you did 2x squared plus 1x minus 6x minus 3, meet me in like 2 steps. Okay? Now, whatever you're doing, you've got 4 terms. Split it in half. Pick the GCF of the first 2. My GCF of the first 2 is 2x. And then in my parentheses, x minus 3. If you went the opposite ways of me, your GCF is just an x. Okay? Then, what's my GCF of 1x minus 3?
X. 1. Sorry.
1?
Sorry.
Positive or negative 1? Plus 1. So when I factor out a 1, I'm left with, in parentheses, x minus 3. Okay? So, matching parentheses, right? That's a good thing. One set of my parentheses are the GCFs of 2x plus 1 and my matching x minus 3. If you had the other order, you had matching 2x plus 1s and GCF of x minus 3, right?
Yes.
Okay, now what?
Set it equal to 0.
Set each part equal to 0. So 2x plus 1 equals 0. X minus 3 equals 0. 2x equals negative 1. X is negative 1/2. And x is 3.
Oh, you're gonna check him.
Because we're working with rational equations, okay, equations that have your fractions, that have variables in the denominator, check your solutions. What's the easy check? And why is it 3 working?
It makes the denominator easier.
If one of my factors in my denominator is x minus 3, that automatically means 3 can't work. What's the other value we know couldn't work for sure? 1. But I got 1 negative 1/2. So this value should work. Okay? That one wouldn't be horrible if with your use of your calculator to go up and plug it in, because you can just type in a negative 0.5. But I can pretty confident in saying you can pretty much check the denominators and that will solve the issue.
Should we check it? Just-
You don't have to.
I trust that you know what you're doing.
So do I. I just want to check my next steps because.
Okay. One more. Okay. Thoughts as we look at example 4?
X may equal 0, -2.
Okay, how do we solve though?
Factor.
Okay. What do I need to factor?
The x squared equals 2x.
That x is a basic factor. That's one of my denominators. X plus 2 is a basic factor. That's one of my denominators. X squared plus 2x? Not quite so basic. Can it factor?
Yes.
Yes. X squared plus 2x has a GCF of x. And when you factor out that GCF of x, you just so happen to get x plus 2.
Me too.
Hey, what do you notice?
You just multiply that part.
Okay.
Yay.
I have x's as factors and x plus 2's as factors. So what am I multiplying every part of this equation by?
X times x plus 2.
Okay, so we're going to multiply an x and x plus 2. What we do on the left,
You're on the right.
we do on the right. Okay. This x times x plus 2 has to multiply by all three fractions, right? So on the first fraction, what happens? X cancels with x, and we're left with x plus 2, x minus 3. I personally will multiply out in the next step. You do you. What happens with the second fraction? X plus 2 cancels with x plus 2. What remains? X with the 3 that's already on top. So 3x. Plus, what happens in the next fraction?
Oh my gosh, plus 6.
X cancels with x. X plus 2 cancels with x. My denominator is gone, and I'm left with just the numerator of 6. What happens on the right? 0 times anything is 0. Okay.
I got x squared.
Shall we multiply now?
0.
So if I FOIL this, x squared minus 3x plus 2x is going to be minus x minus 6. And I still have the plus 3x and plus 6.
Oh my gosh, I forgot a number. Oh my gosh.
Am I okay so far?
Yep.
Now I'm going to clean up like terms. X squared plus 2x. 6's cancel equals 0.
I know.
I got everything
I
else.
was like, oh my gosh, wait.
I forgot the minus 6, so I only had the plus 6.
How do I continue?
Factor it out.
Okay, we're going to factor. What type of factoring is there here? It's a GCF. So if I factor out GCF, I'm left with
Oh my gosh.
x plus 2. Set each part equal to 0. So x equals 0. X plus 2 equals 0. And we get our solutions of 0 and negative 2.
Neither of them work.
Okay? We check our solutions. 0. Well, that doesn't work in the first fraction. Negative 2. That doesn't work in the second fraction. What's my answer?
Undefined.
How about just no solution?
In
No,
A.
marks too.
I'm writing in A.
This problem is applicable. It just has no solution. Okay. Your homework is on page 227. 4 through 28. Evens. I think it's like 12 problems. Okay? We just did 4 in class. You guys know you can do yours quicker than I can do them with you as a class usually. So. And you have maybe 8 minutes to work right now. Use it.